Question 25 says, assume a parallel plate capacitor which is maintained at a potential 100 volt. If the partition distance between the plate and the area is 5 mm and 25 cm square respectively, compute the displacement current for the time in 1 microsecond. So we know that displacement current is the displacement current density times area. Displacement current density is epsilon. dE dt is the electric field times area. Now we can approximate this for small time like 1 microsecond as E by T, and epsilon A E is potential by the distance between the plates divided by time. So you can multiply 1 by 4 pi and 4 pi epsilon as a value of 1 by 10 to the 9. Area is 25 into 10 to the power minus 4. Potential is 100 volts divided by 5 into 10 to the power minus 3 into 10 to the power minus 6. So if you calculate this, you are going to get 0.44 milliampere. 24th question says, which of the following statements is incorrect regarding the comparison between Biot-Savart law for magnetic field and Coulomb's law for electrostatic field. So option A says that both are long range, and since both depend inversely on square of the distance from the source to the point of interest, so yes, this is actually correct statement, because both the magnetic field and the electric field in the Biot-Savart law and Coulomb's law is like 1 over r square, and in principle the effect of the force is up to infinity, so it is very long range force. Option B says the electrostatic field is produced by a scalar source, yes, which is the charge, and the magnetic field is produced by vector source. Yes, the current is indeed a vector, but in one dimension we simply use it as scalar because the current follows the wire, so we don't worry about the direction of the vector. But in case of 2 or 3 dimensions, current is a vector quantity. Now option D says the electrostatic field is along displacement vector joining the source and the field point. That is true. The magnetic field is perpendicular to the plane containing the displacement vector and the current element. Yes, because in the Biot-Savart law this is proportional to IDL times the vector r cap divided by r square. So it is both perpendicular to the current element dl and perpendicular to the plane containing the displacement vector. So magnetic field must be perpendicular to both dl cross dl and r. So this is also a correct statement. So the incorrect statement is option C. Alright, so 23rd question says that coefficient of volume expansion of glycerin is this. Find the fractional change in its density for a 20 degree centigrade rise in temperature. So we have to use the fact that mass is something that remains constant when you increase the temperature. So if the increased density is rho, increased volume is V, and the initial density is rho 0 and initial volume is V0, so rho by rho 0 is V0 by V, but we know V is V0 1 plus gamma into 20. Okay, now fractional change by definition means rho minus rho 0 by rho 0. So that is basically rho by rho 0 minus 1. So that is 1 by 1 plus 20 gamma minus 1. That is 20 into gamma is 49 10 to the minus 5 divided by 1 plus 20 into 49 10 to the minus 5. If you calculate, you will get option D. 22nd question says a brass boiler has base area 0.2 meter square, thickness 1 centimeter. It boils water at a rate of 6 kg per minute when placed on a gas stove. Calculate the temperature of the part of the flame which is in contact with the boiler, and all the details are given. So we know the rate of change, sorry, the heat that is uh, coming to the water per unit second is thermal conductivity minus the boiler temperature theta minus 100 into the area which is 0.2 divided by the thickness 0.10 to the power minus 2. Now to boil water at 6 kg per minute, that is 6 by 60, 110 kg per second, you need to provide the heat 2256 into 10 to the power 3 by 10 joule per second to boil water at a rate 6 kg per minute. Okay, so you have to put the value 2256 into 10 to the power 2 here and put the value of K here, which is 109 into theta minus 100 into 0.2 by 10 to the minus 2, and you have to calculate this value of theta, and you will see indeed the answer is option D, 203.48 degrees centigrade. 21st problem says the below figure shows a ball of mass 0.6 kg rebounding between two walls separated by a distance of 2 centimeters. The ball rebounds between the wall every 2 seconds with a uniform velocity. Find the magnitude of each impulse. So when the ball is approaching the wall, let's say this is x direction, so it has a velocity 2 centimeter by 2 second, that is 1 centimeter per second. So the initial momentum is along positive x direction. The initial momentum is 0.6 into 10 to the power minus 2 kg meter per second, and let's say this is p, and when it rebounds from the wall, then it would have a momentum minus p. So change of momentum is basically p minus minus p, that is 2p. So 2 into 0.6 into 10 to the power minus 2, you will get 12 into 10 to the power minus 3 kg meter per second. So none of the answers are matching. So I think this is the right answer, and the official answer given is option A. There is a problem in the exponent, but I hope you got the idea. So now 20th problem says a galvanometer coil has a resistance 14 ohm. The meter shows a full scale deflection for a current 4 milliampere. How will you convert the meter into a voltmeter between 0 to 16 volt? So basically, as we know, to convert a galvanometer to a voltmeter, you need to add a high resistance in series with it. The idea is if you provide a potential of 16 volt between this system, then the maximum current the galvanometer can afford is 4 milliampere. So as I know, I is 16 volts divided by resistance of galvanometer plus R. So I is known as 4 into 10 to the power minus 3. This is 16. 14 plus r. So you invert the equation, so you will get 14 plus r is 4 into 10 to the power 3. So r must be 4000 minus 14, which is 3986 ohm. Option C. Now 19th problem says a train runs along a unbanked circular track of radius 10 meter at a speed 30 km/h. The mass of the train is 10 to the 6 kg. And what is the angle of banking required to prevent wearing out of the trail? So suppose the banking has an angle theta, and let's assume this is the train, this is the normal force, this is the mg, this is the perpendicular direction, this angle is also theta, right? So you have a centrifugal acceleration, centrifugal force here, F. So so if this angle is theta, this angle is also theta. So n cos theta must balance mg, and n sin theta must balance the centrifugal force, which is mv square by r. So tan theta is v square by rg, which is 36 into 5 by 18 square into 1 by 10 into 10. So this is 1. That means theta is 45 degrees. Option A. A uniform electric field of 50 volt per meter is directed at 30 degree with positive x-axis as shown in the figure, and the distance OA and OB are given, and the potential difference between VB minus VA and VO minus VA. So we'll try to solve for this first, because the options are different for V0 minus VB. As you can see, the signs are different here, and so it will be beneficial to do the second problem first. So as we know from the definition, V0 minus VA must be equal to minus A to O into E times dl. So along this direction AO, dl is basically dx into x cap, assuming this is x and this is y, and so that would be A to 0. This is E dot x cap into dl, that is A to 0 E cosine 30 degree. Sorry, this is dx, this is dx. So this is minus E root 3 by 2, and you have x for the position 0 and position A. Now A has the coordinates minus 6 comma 0, so that is 50 into root 3 by 2 with the minus sign. This is 0 minus minus 6, that is minus 150 root 3 volts. So option A is only correct, because option C has no minus sign here. Okay. In a plane electromagnetic wave, the electric field oscillates sinusoidally at a frequency this and has an amplitude this, the amplitude of the oscillating magnetic field. So oscillating magnetic field of the electromagnetic wave has the amplitude the amplitude of electric field divided by c. C is the speed of light, so 36 by 3 into 10 to the power 8. So this is 12 into 10 to the power minus 8, that is 1.2 into 10 to the power minus 7. Option D. The radii of the faces of double convex lens are at 20 cm and 30 cm. So if the focal length of lens is 36 cm, find the refractive index of the material. So you have to use the lens maker's equation, which is 1 by the focal length is the refractive index minus 1 divided by 1 by r1 minus 1 by r2. So since the convex lens is double convex, so r1 is positive, r2 is negative. So if I plug in these values, 1 by 36 is mu minus 1 to 1 by 20 plus 1 by 30, that is mu minus 1, 5 by 60, which is, that means mu is 1 plus 1 by 3, that is 1.33. I think option A is correct, but it is given that option C is correct in the official answer key. And if you know how to get this answer, please comment in the comment box, but I think option A is correct. Thank you.